Hey everybody, it's Matt.
And Mark, and we're here to talk about some developments in the cancer field in recent years and to let you know that sugar has a direct correlation to increased chances and effects in multiple cancers. What does this mean? It means that sugar can increase your chance of cancer and the development of various cancers. To prove this, we found a couple studies pertaining to multiple types of cancers that show the underlying mechanisms that sugar affects in different cancers and how they lead to the development of that cancer. However, Matt was not entirely convinced, so he found some work that also disproves our claim and mitigates the extent to which we have claimed sugar affects cancer development. We found that some cancers are more glucose dependent than others, but despite this, glucose still has a significant effect on both cancers' development. It was seen in two breast cancer types, MCF7 and MB231, that when treated with higher glucose concentrations, both showed significant increases in cell growth over 72 hours. In MB231, there were significant increases in glucose transporter expression, specifically the transporters hexokinase 2 and pyruvate kinase. These are enzymes responsible for processing glucose. While in MCF, only the glucose transporter pyruvate kinase rose significantly. The rises in MB231 were more significant than the rise in MCF7, displaying that some cancer types like MB231 are more glucose dependent and the effects of glucose will be more drastic in these cancers. Some cancers like MB231 are better at utilizing the glucose in their environment than others. It was seen through fluorescence that over 72 hours in higher concentrations of glucose, the amount of glucose uptake in MCF7 did not change, whereas the uptake of MB231 increased significantly. But as said before, just because a cancer isn't more glucose dependent doesn't mean it still doesn't have an effect. It was seen in MB231 and the less glucose dependent MCF7 that high glucose levels contributed significantly to the migration percent of both cancers. Migration percent is the percent of healthy cells migrated to by cancerous cells. When treated with an inhibitor of glucose, the migration percent of both cancers were decreased significantly, with a more significant decrease seen in the more glucose-dependent cancer type, MB231. In MB231, the more glucose-dependent cancer, the inhibition of glucose had more significant effects than in the less glucose-dependent cancer, MCF7. This means that glucose uptake could be a possible treatment target for these more glucose-dependent cancers. Two more interesting studies found that two pathways contribute to the uptake of glucose. The first is the EGFR to STAT3 to FOXM1. EGF is external growth factor, and EGFR is the external growth factor receptor. In two cell lines, KKU213A and KKU213B, of cholangiocarcinoma, referred to as CCA, which came from a single Thai patient, which was a limitation of this study. It was found that cells of both 213A and 213B in high glucose had significantly increased FOXM1 expression. When FOXM1 was silenced using small interfering FOXM1, both cell line A and B, when in normal or high glucose, showed decreased migration rate and invasion rate, showing that FOXM1 plays a significant contribution to the progression of CCA. FOXM1 is regulated by three signaling proteins, AKT, ERK, and STAT3. When STAT3 was inhibited using static, a significant decrease in FOXM1 expression was seen in both cancer cell lines A and B, displaying that increased STAT3 led to the increased FOXM1 expression.
But how did they know it was STAT3 and not ERK or AKT?
Well, they did test ERK alone and found that when ERK was inhibited, it had very little effect on FOXM1 expression, because FOXM1 expression did not change significantly. AKT, however, was not tested individually, which is a limitation of this study and these results. STAT3 is mediated by the external growth factor and external growth factor receptor signaling. In high glucose environments, EGFR signaling is activated without EGF binding, leading to increased signaling, and thus STAT3 production is increased, leading to increased FOXM1 expression. This is one underlying pathway that connects high glucose to increased CCA development, making this pathway a possible target for treatment and other therapeutic strategies, such as tyrosine kinase inhibitors that target the EGF-EGFR signaling, or a drug that helps regulate STAT3 production despite increased EGF-EGFR signaling taking place. Another possible underlying pathway that connects glucose to increased cancer risk and progression is the GLUT1 pathway. A study looked at what effects mRNA-451 had on the GLUT1 pathway after hypothesizing it has an effect on glucose metabolism. It was found in two cell lines of glioma, LN229 and U87, that when treated with a lentivirus, one a control and one with added mRNA-51, that in both cell lines treated with the mRNA-451 lentivirus had increased mRNA-451 expression, and subsequently significantly decreased GLUT1 expression. Multiple proteins were downregulated in addition to GLUT1. They also happen to form a pathway, beginning with CAB39, going to LKBI to AMPK to P13K and AKT, and end with GLUT1. So it was hypothesized mRNA 451 might attack CAB39, but this hypothesis was never tested in this study, making it a limitation.
So then, could CAB39 be a possible target for treatments?
Well, since this is just hypothesized research and nothing's clear enough from this study, all we can tell from these results is that mRNA 451 downregulates all these proteins. Because every protein in the pathway is downregulated, we can make a strong inference that CAB39 may be what's being attacked, but further research would need to be performed to find out if this is true. mRNA 451's adjustment to glucose metabolism resulted in significant tumor suppression. Cell proliferation, invasion, and migration were all significantly decreased, as well as decreases in proteins such as cyclin D, which are necessary for the cell cycle. When tested in mice, it was seen that in the group treated with the mRNA 451 lentivirus, tumor growth curbed and began decreasing after a short time, and tumor growth was significantly decreased. Further, mRNA 451 group had significantly longer survival rates and significantly reduced GLUT1 expression. However, these results have a huge limitation. Unlike previous experiments, this one was only performed using the U87 cell line of glioma.
So then, was any portion of this study performed in people?
No, none of this study was performed in people, only mice, which also makes us another limitation, as the tumor environment of a human is much different than the tumor environment of a mouse. These results show the effectiveness of decreasing GLUT1 expression in these cancer types, making this a strong target for treatment. Possible targets to allow this should be found by investigating the hypothesized pathway properly. If mRNA 451 really downregulates GLUT1 by attacking CAB39 and downregulating the entire subsequent pathway, then CAB39 and subsequent proteins could be further targets for many treatments, as Matt mentioned before.
You know, the mechanistic work is actually pretty impressive, but I'm not entirely convinced this actually happens in humans. So I went ahead and I found some studies that look at sugar intake and cancer risk at the population level. And honestly, the human evidence doesn't really match the mechanistic predictions. We all know that sugar intake is connected to obesity and type 2 diabetes, and both of these conditions are known risk factors for pancreatic cancer. So it seems logical that sugary intake might raise cancer risk too. So, to test this idea, researchers used the EPIC study, one of the biggest nutrition and health cohorts in the world, including almost 500,000 adults from 10 European countries. Following these people for 12 years, they identified 865 cases of pancreatic cancer during that time. Soft drinks showed no association with pancreatic cancer. Across all models, basically whether participants drank soda or not, it didn't seem to change their risk. An even bigger surprise was that juice and nectar intake was associated with a lower risk, even after adjusting for BMI, energy intake, and diabetes, meaning it wasn't just healthier people drink juice. This directly contradicts the assumption that any sugary drink increases pancreatic cancer risk. These drinks contain natural sugars, sometimes added sugars, yet the trend went the opposite direction.
You just said that juice and nectar actually showed an inverse association. Can you explain why that was surprising and what it might mean biologically?
Yeah, that part of the study really stood out to me. Going into this, you'd expect sugary beverages to increase pancreatic cancer risk. Biologically speaking, there are a few possible explanations. Juice isn't just sugar. They have antioxidants and phytochemicals. Compounds like vitamin C, carotenoids, polyphenols, and flavonoids can reduce oxidative stress, lower inflammation, improve DNA repair, and support normal pancreatic function. These effects could offset the potential risks of sugar. There was also one subgroup that showed any increased risk, and that was women who drank artificially sweetened soft drinks, showing a small but significant positive association. The authors did note, however, that this was probably due to reverse causation, meaning women with higher diabetes or obesity risks may switch to diet drinks because they are already metabolically at risk, not because the drinks cause cancer. There were several acknowledged limitations. Diet was measured once at the baseline. They couldn't distinguish beverages with or without added sugars. All intake data was self-reported, which can distort accuracy. This challenges a lot of assumptions about sugar and cancer, because pancreatic cancer is one of the cancers most strongly linked to metabolic health. If sugar-sweetened beverages were going to strongly raise risk anywhere, this would be the place to see it. Although elevated sugar consumption may play a role in cancer development under some circumstances, it's not generally definitive. A review done by Hassan et al. Questioned this. Why do people believe sugar feeds cancer? Well, the reasoning is pretty intuitive. High sugar intake leads to high blood glucose, more insulin release, and insulin and IGF-1 activate growth pathways in the cells. Cancer cells already love glycolysis, and chronic high sugar diets lead to more inflammation and metabolic dysfunction. Because of this, people assume sugar directly accelerates cancer. The review acknowledges these mechanisms, especially insulin resistance, IGF signaling, hyperglycemia induced inflammation, and fructose driven fatty liver disease, all of which can create environments that support cancer cell survival and proliferation. For example, fructose metabolism in the liver increases uric acid and oxidative stress, and glucose metabolism fuels ATP production that tumors can exploit. There is a major theme throughout the article. Even though the molecular pathways sound convincing, the authors repeatedly point out that the actual human evidence is mixed. They also show that population studies do not consistently link sugar intake to cancer risk, even in cancers that are metabolically sensitive. They reviewed studies that both supported the sugar feeds cancer hypothesis and the opposite. There is no denial that sugar can play a role, especially when it worsens metabolic disease. The contradictory evidence strongly undermines the simplistic sugar feeds cancer narrative. There's also a metabolic difference between sugars and how they're broken down. Glucose driving insulin release in IGF pathways, fructose primarily metabolized by the liver, and sucrose has the combined effects of glucose and fructose. It's important to make the distinction because many human studies lump all sugars together, masking the real effects of individual types. Sugar doesn't always have an effect on the metabolism of cancer. It also affects cancer treatment. Hyperglycemia can reduce treatment effectiveness by polarizing tumor macrophages and drug resistance pathways, increasing GLUT1 expression and drug resistance pathways, and weakening T cell function in nutrient-restricted tumor environments. This suggests that sugar doesn't necessarily cause cancer, but it may make some cancers harder to treat if metabolic dysfunction is present. Future directions for studies are geared towards metabolic targeting, not sugar elimination. Emerging strategies include dual inhibition of glycolysis and oxidative phosphorylation, treating GLUT transports, manipulating T cell metabolism, and uncovering glucose-glutamine interactions. These interventions focus on disrupting the fuel supply of cancer. High sugar intake may contribute to cancer through metabolic and inflammatory pathways, but the evidence is inconsistent and not universally conclusive. Because high GI foods can spike blood sugar and insulin, potentially activating pathways like P13K/AKT and IGF-1, researchers examined whether GI or GL influenced lung cancer risk. They used the Southern Community Cohort Study, a large and diverse U.S. population, over 55,000 low-income adults, and followed participants for nearly 10 years. Despite the biological rationale, there was no association between GI, GL, and lung cancer risk. The crude data initially showed trends, but once smoking was adjusted for, all associations disappeared. Stratified analyses by sex, race, income, obesity, smoking status, and tumor type also showed no significant trends.
Why did the crude data originally suggest an association? And how did adjusting for smoking change that interpretation?
That's actually a really important point in this study because it shows how misleading raw data can be if you don't consider confounders. Before adjustment, it actually looked like people eating higher glycemic index diets had higher lung cancer rates. As soon as they adjusted for smoking, however, the pattern basically disappeared because smoking is such a powerful risk factor for lung cancer that it can completely overshadow dietary effects. The authors noted that earlier case control studies reporting positive associations were likely influenced by recall or survival bias. Limitations of this study included reliance on baseline dietary data, possible undiagnosed diabetes, self-reported intake, small subgroups, and limited generalizability beyond similar low-income Black and white populations. Another study proposed that the polyol pathway, not glucose itself, is the key mediator of the aggressive cancer phenotype. It was hypothesized that activation of PP enzymes, particularly AKR1B1, aldose reductase, and SORD, sorbitol dehydrogenase, promotes epithelial to mesenchymal transition, EMT, which enhances cancer invasiveness and stemness. Cell lines from breast, lung, ovarian, colon, and renal cancer were tested. It was found that AKR1B1 and SORD are overexpressed in aggressive cancers. The PP enzymes correlated strongly with mesenchymal markers, VIM, ZEB1, and low ECAD herin. High AKR1B1 expression predicted poor prognosis in lung, ovarian, and gastric cancers. They also found that inhibition of the PP reverses EMT. When they knocked down AKR1B1 or SORD, it restored epithelial morphology, increased ECAD herin, and decreased migration and proliferation. Overexpression of AKR1B1, however, had the opposite effect, promoting EMT and proliferation. Something very interesting, however, was that high glucose increased EMT markers, but only in cells with an intact polyol pathway. PP-deficient cells were resistant to high glucose-induced EMT. This indicates that sugar's cancer-promoting effects require metabolic conversion via the polyol pathway, not simply sugar exposure.
It was really interesting to see how exactly sugar can contribute to the effects glucose has on a cancer, and why those effects happen, like from EGF signaling to increased FOXM1, an oncogene, or the tumor suppressing effects of downregulating GLUT1. It made me feel a little scared of sugar for a while. It's a vice that I only take notice of before going to the dentist, but now I see this bad habit in a completely different light. But thankfully, Matt's research brought me back to reality.
My takeaway is this: sugar doesn't directly cause cancer in humans, but certain cancers can use glucose to become more aggressive once they already exist. Human studies showed us that sugar consumption does not consistently increase cancer risk, and the effects vary dramatically across cancer types. Confounders like smoking, obesity, diabetes matter more than sugar intake itself. I think you should worry about diabetes long before worrying about sugar directly causing cancer.